Boyle's law. At a constant temperature, the product of an ideal gas's pressure and the volume is always constant. In other words, when the temperature is constant, P1 times V1 equals P2 times V2. In this experiment, we put a semi-inflated balloon inside of a wine bottle. We then turn the bottle into a vacuum with the help of a wine pump. As you can see, the balloon's volume increases as the pressure in the bottle decreases. Once I restore pressure to the bottle, the balloon's volume decreases again.
Charles' law states that for an ideal gas at constant pressure, the volume is directly proportional to the absolute temperature in Kelvin, otherwise known as V1 over T1 equals V2 over T2. In this experiment, we crush a ping pong ball without puncturing it. Then we put it in boiling water so that as the temperature increases, the pressure builds inside of the ping pong ball, pushing the sides back out and making the ball whole again.
Gay-Lussac's law. The pressure exerted on a container's sides by an ideal gas is proportional to the absolute temperature. P1 over T1 equals P2 over T2. In this experiment, we lit a piece of paper on fire inside of a bottle and put a hard-boiled egg on top. Once the fire went out and the egg sealed the container, the temperature dropped. Because the temperature dropped, the pressure in the bottle increased enough for the egg to be sucked in.
No, I wanted that!
We did a similar experiment, but this time the pressure increase sucked water up into the cup.
Avogadro's law. The volume occupied by an ideal gas is proportional to the number of moles present in the container. V1 over N1 equals V2 over N2, where N equals the number of moles. In this experiment, I blew carbon dioxide into the balloon. The more moles of CO2 I blew into the balloon, the bigger the balloon got. As I let the moles of CO2 out, the balloon shrunk.
Dalton's law. The total pressure exerted by the mixture of non-reactive gases is equal to the sum of the partial pressures of each individual gas. P total equals P1 plus P2 plus P3, and so forth. In this example, the 300 milliliters of red, 200 milliliters of green, and 100 milliliters of blue water represent different gases. As we add all of the so-called gases to one container, their volumes, which represent pressure, all add together to 600 milliliters total.
The ideal gas law describes the relationship between pressure, volume, number of moles, and temperature. It is a combination of Lussac's law, Boyle's law, and Charles' law. Pressure times volume equals number of moles times constant R, which is 0.0821, times temperature in Kelvin. For this experiment, we put 8 Mentos into a balloon, put the balloon over the top of a 1.25 liter bottle and a 2 liter bottle of Diet Coke, and dumped the Mentos in. There were more moles of Diet Coke in the 2 liter bottle, and therefore the balloon on the 2 liter bottle filled to a larger volume.
It was approximately 65 centimeters in circumference.
Focus. 56.